Right, afternoon everyone. So I'm here presenting on behalf of the DMAC. So just to show everybody, the DMAC is a big group of people who contribute to the management of the data or acquiring the data. It's a big group. There are many players from across the projects and also within the DMAC that contribute to I just need to move myself out of the way. Right. So I just want to acknowledge everybody because this is a big team that contribute to the making the projects a success. So just a very brief recap of what the DMAC's mandate is. And we are there really to provide a data management platform and provide technical support so that the projects and cores can work seamlessly together. We have 4 aims. The first is to develop this scalable platform that can coordinate the tools, the workflows across the different groups in the consortia. We also provide access to the data sets. And we have this third aim about leveraging our Omnix experience. So we are the DMAC and NGS core. And then we also contribute to training, but I'm not going to talk a lot about training, so I've made it a little bit grey here. So just in terms of aim 1 about the scalable platform, for the projects, we get data from multiple different sources. So a few of them are represented on the left. And all of these databases come into a central point where they are cleaned, checked for quality, and the harmonization occurs. The platform where we interact with the data is the OSF, so people can upload and download data. And eventually, in this framework, we can put the work streams onto a Terra platform, which is a cloud-based platform where individuals can go if they want to do analysis and don't necessarily have the compute power in their own local computer. So in our DMAC, we have this tracking database, which is to track all of the databases that we have. So this is to try and have an overall picture of where we are. So we track the accessibility. Sorry, I need my glasses. The status. We track whether it the data sharing, so whether it can or can't be shared, and then also the kind of data that we're collecting, whether it's genomic or SARS-CoV-2 data or HIV data. We also look at the whether it's which country, whether it's Nigeria, South Africa, or global data. And this is just so we have an overall picture. And then the accessibility about whether the data is public or not public. So just a summary of the data characteristics of what we have so far. So firstly, in terms of distribution, half of the databases are on Nigeria, and then the rest are made up of data from South Africa or global data. In terms of the disease, most or 3/4 of the databases are on SARS-CoV-2, and the rest on HIV. And then in terms of what kinds of data we're collecting, we have a mixture of genomic, clinical. Our biggest data sets are our population health information. Then we have mobility data, geospatial data, and then climatic data. And then in terms of the harmonization and availability, so these databases come in. Some need some form of harmonization across them because they all are derived from multiple different sources and cover. So the harmonization talks to trying to make the databases shareable and have similar variables. So in terms of the harmonization, there are several public databases. Harmonization has been completed for some, as in process for some. There are about a quarter of the databases don't need harmonization. And we also have this little pie that is called still in negotiation. So it's, I want to just mention that and talk about it because I think we need to discuss them. And then in terms of availability, most of the databases are available on either through a public link or through OSF. And that chunk, that little pie there that says no, not available, are those that are still under negotiation. So in terms of data sharing, so we share data amongst ourselves across the projects, but the idea is also to eventually share the data with the DSI. So this is just giving us a picture of what can't be shared and what is currently shared, and what would need to be requested from the data suppliers. So we have data sharing agreements from different suppliers. We don't have permission to pass it on to a third party. So there is limitations in what we can share. So there's also this data sharing policy or guideline that's been developed, which is very helpful in how we can eventually share and what and how we can share the data. But I think one of the things we may need to discuss in our consortium is whether we wanted to make a data access committee, because this comes up in the guideline and they talk about having a central data access committee, but we haven't really spoken about whether we wanted one at a project level. So I think we do need to talk about that. So these are the data sets that have been problematic, either not able to access them or have been in negotiation since the beginning of the project. So I think we need to make a decision about whether we should keep pursuing these or whether the project can answer the objectives without trying to get them. We also collaborate with the Al-Wazi group, so we work closely with them, and so this the PIs would have received a request to mark the variables that they use in the databases. So this is hundreds and hundreds of variables from across the different databases. And the reason why we ask for that information is because it feeds into the Al-Wazi metadata platform. So we'll talk more about that just now it comes up again. But in terms of the long-term plan and the scalable platform, so Joycey and her team have been working hard in the background, and so a lot of this work has been taken on by Danilo, and we conducted a review of all the open source software that is available, and so this little spider diagram on the side there shows the review of all the open source software that was reviewed, and the conclusion and the what we've decided to go forward with is this lakehouse infrastructure as a tool. And what this tool allows you to do is you can manage the credentials, you can give people passports in order to access it. So Joycey will be able to explain much better than me, but you will be able to interact through your own computer, through a Python or an R package, and be able to make queries in the database, to query, to do searches on the databases. So it improves the interaction with the databases and the data frames. You can upload and download data. But the most important feature of this data lake, the lakehouse, is about data versioning, so that anytime somebody accesses the database or changes it, there is version control, but also allows data reusability, and it will have this cloud integration. So this is just about the harmonization and data on the OSF, the cleaning. It is just one slide, but this cleaning and the harmonization is a big job and takes a lot of time. So it does consume a lot of people's energy. But we are working, this is just describing the harmonization, just going quickly. This is just an example. So this is an example showing the same fields in two different data sets get called different things. So in the NICD data set, the variable gender is called sex in the Nigeria COVID database. And then the age is recorded as a numeric value, but in the NICD, in the Nigeria CDC database, it's an approximate age. So the whole harmonization is to try and come up with a common term, so that when you're talking about age, you know you're talking about the same thing across different databases and gender. So there are these certain variables that can be harmonized. So where it makes sense, we need to do that across all the databases. We're also working with the Elawazi group and using their harmonization tool. So Michelle Parker from our team works quite closely with Catherine Johnson from the Elawazi group, working on the harmonization. This is just a picture from the Data Jamboree. So Elawazi organize trainings, and we try and participate, so to make sure that we have this link with the bigger DSI consortium. We're also contributing to the Elawazi data catalogs. So this is just the metadata, so it's not sharing data, it's just sharing characteristics of our data sets. And then finally about our Omnix, leveraging our Omnix experience. So Kristen's already spoken about the collaboration between Project 1, Project 2, and the DMAC. And the idea here is to use the mobility data, the genomics data, to track the different in the two different countries and the variants of concern, to give another layer. And so this is an ongoing project that we are all working on. And then Joycey will speak about her pilot project, but I think will be quite important for pandemic preparedness. I'm wrapping up. And so this is about applying machine learning and other tools to make variant assignment much easier. And this has been a very productive student who is going to produce 3 papers on alignment-free techniques. And basically what he does is he manages to reduce what takes many hours into like minutes. So he's applying machine learning techniques in order to classify variants. So the important thing here is he used SARS-CoV-2 as a start, but this can be applied to other infections. So dengue, HIV. We've just worked on a new classification system for dengue. And so now he's also applying this tool to dengue and is working on other papers. I won't steal Joyce's thunder, but the point I want to make in this one is we have a nice collaboration with the African Institute for Mathematical Science. And these are all AI students that link up with us to do small little projects. They're master's students. But they are very well-trained mathematicians, so they have. It's been a really good collaboration. So if we're looking at that AI in the future, I think it will be important to involve people from the computer science and things into this. But if you want to talk more, Joyce supervised both these students about. This was looking at public announcement. Okay. Okay. And that's all, and I'm sorry for going over time. But we've been very busy. So, thank you. Okay.